Now, let's see how rational exponents work. Okay, we have a look now. We have numerical expressions with rational exponents, very important, key, but I'm going to deal with numbers first. Okay, maybe later the variables. Consider the following rational numbers. Are they rational? Okay, we've been told that they're rational. We don't have to work them out, but to apply the exponential laws here. Okay, 8 squared is 64. Cube root of 64, you know it, as 4. Cool. And then another way, you can start by divide this number exponent divided by that 3, the cube root of. So 2 divided by 3 is what we do. Always the inside exponent divided by the outside number. This number must always come at the bottom. It's never on top, at the bottom. And use your expressions, your powers, the knowledge of powers. 8 is 2 cubed. Then do some multiplication, you get 2 squared, which is 4. That gets to 4. This is another way of dealing with it. Okay, now, we're saying, quickly, we're saying this is 2 over 3, as I said. You can move from here to there, okay? Now, in general, we're saying, we're calling this Mandela rule, of course. This is M on top over N. I highlighted that, M over N. Then this is the general rule that I talked about. Now, let's see further examples. The 10th root of 32 squared. Guys, the 10th root, that number means the 10th root. It doesn't mean 10 times. We tend to misinterpret these numbers. The number is a small number on top, meaning the 10th root. Okay, we're doing that Mandela rule thing. The inside exponent divided by the 10. Let's see. So we quickly go 2 over 10. So what do we do? And then you can simplify your exponent to make this easy. Then it simplifies to 1 over 5, or a fifth. Get to know your powers. 32, what is it? 2 to exponent 5. Multiplication of exponents, you get 2. Now, example 2, square root of decimal. Quickly, this is easy work. Convert it to common, 4 over 100. Am I right? 4 over 100. Good. Then you have a square there. And it's up to you. There is invisible 2. Divide that 2 by 2. You get 1. Or you simplify this further. First, I like simplify this first. Let's see. You make it 1 over 25. And you still have your 2 there. Now your answer is already 1 over 25 because this is going to cancel. It's going to be 2 over 2. But there is another way of doing it. We're saying 1 over 25 is 5 to negative 2. Then you have times 2, which is square root of 5 to negative 4. Then what do we do? Negative 4 divided by 2. We have 5 to negative 2. Look at that, 5 to negative 2, which goes back to 1 over 25. We had the answer already. Now, example 3, the same as the previous one. What do? Work out the inside first if you can. If you can't, just apply your Mandela rule, and then you get the answer. Let's see how to apply this. Now, this, as I said, is 3 over 4. Yes, we went straight to Mandela rule. Straight to Mandela rule. And then, look at it. I express 625 and 81 as both as power exponent 4. Look, get to know your powers, guys, as I said. Now multiply each. This times that and times the bottom. What do you have? 5, 2, 3, 3, 2, 3 as we multiplied. Now simplify. 5 cubed, 125. 3 cubed, 27. That is now your answer. Example 4. Example 4 is not actually, the whole thing doesn't show Mandela rule. Mandela rule lies inside the brackets. Let's see how Mandela rule works inside the brackets. Now, here is where you have Mandela rule, but the main thing is not actually Mandela rule. It's here. Let's go. And then we have 3 cube root of this over square root of x. Now, take this back to exponents. Remove caps. These are the caps. Take them out. Take your caps out. How? Using Mandela rule 2 divided by 3 over 1 over 2. And then we have simplified like this. Okay, you simplify this. Remember subtracting. the exponents when you divide the powers with the same basis. Add this, guys, easy stuff. Then you multiply 2x. Cool. May we look at another example? Rewrite this with a rational denominator. Look at your denominator. 2 over square root of 3 is irrational. We sometimes say rationalize your denominator. Make it a rational number. So watch the method we're using behind. We always say 2 over 3, then you multiply that by 1. Okay, I just introduced 1. Look at 1 here, multiplied by 1. Meaning, I'm not changing anything by multiplying by 1. Remember, 1 is an element of multiplication. You cannot change anything. And then what do? That 1 is going to be manipulated into this. I'm going to make 1 root 3 over 3. Because root 3 over 3 still divides to 1. So I'm manipulating it, and then I get 2 over square root of 3 times that. Look, this is the manipulation. This is the same as your 1. Look, just cancel it. Use the concept of cancel. You still go back to 1. This is manipulation, but in a clever manner, knowing that square root of 3 times square root of 3 gives me a rational number of 3. Remember? Then you have 2 root 3 over 3. This is what we call, we write in denominator as a rational number. Sometimes the question may say, rationalize your denominator. Look at the bottom part, make times 1, then your bottom part must be numerator and denominator when you simplify it. Guys, see you in the next lessons. Bye.